There is a $30 fix and a $600 fix for a car that shakes at highway speed. The difference between which one you walk out of the shop with has nothing to do with the severity of your shake. It has nothing to do with your car's age, your mileage, or your driving habits. It depends entirely on whether the mechanic diagnosing your car asks you one specific question before they put it on the lift. Most of them do not ask it. Most of them already know what they are going to recommend before you finish describing the problem. And the recommendation is almost never the $30 fix first. Stay with me. I'm Tyler Williams. Most people know me as Motor Grease Monkey. 15 years in garages chasing down vibrations that drivers couldn't explain, but could definitely feel. Every year, millions of Americans search Google for some version of the same question. Why does my car vibrate on the highway? Why does my steering wheel shake at speed? Why does my car shimmy above 60 miles per hour? It is one of the most common mechanical complaints in automotive history, and it has been generating unnecessary repair bills for decades. Because here is the thing that every mechanic knows, and almost no driver does. A car that shakes at highway speed is not one problem. It is three completely different problems that feel almost identical from the driver's seat. And those three problems cost $30, $300, and $600 respectively. The only way to know which one you have is to understand the diagnostic pattern, the specific set of questions about when, where, and how the shake behaves. That points you directly to the cause before a single tool has been picked up. Today I am going to give you that diagnostic pattern. By the end of this video, you will be able to identify which of the three causes is producing your shake, based on what you feel when you feel it and where in the car you feel it. You will walk into any shop knowing exactly what they should be looking for, and exactly what the repair should cost, and you will know whether that mechanic asked the right question first. Here is the diagnostic framework. It takes 2 minutes to run through, and it is the same process every competent mechanic uses. The first question is, does the shake change when you press the brakes? Take the car to a highway, get to the speed where you feel the shake, and note what happens when you apply the brakes. Does the shaking get worse? Does it change in character? Does the steering wheel pulse rhythmically in and out, rather than just vibrating? Or does the shake stay exactly the same, whether your foot is on the brake or not? If the shake gets worse or changes character under braking, especially if you feel it pulsing through the brake pedal itself, you have answered the question. That is not a balance problem. That is a rotor problem. Skip straight to section 2. If the shake stays the same whether you are braking or not, move to question 2. The second question is, does the shake change with speed? Does it appear at a specific speed, say between 65 and 75 miles per hour, and then smooth out above that range? Or does it get progressively worse the faster you go, with no smooth out point? Or is it a constant droning vibration that is present at most speeds, and seems to pull slightly to one side? If the shake appears at a specific speed window and smooths out above it, that is an out-of-balance wheel. That is a $30 fix. Section 1. If it gets consistently worse with speed, and there is a growling or droning component to it, particularly if it changes when you change lanes, or shift your weight through a curve, that is a wheel bearing. The $30 fix that most shops never suggest first. Every wheel and tire combination on your car is not perfectly symmetrical. Tires are manufactured with minor weight variations across their circumference. Wheels have small inconsistencies in their casting or stamping. When those two imperfections align in the wrong direction, the combined wheel and tire assembly is heavier on one side than the other. At low speeds this makes no difference. As speed increases, that small weight imbalance begins generating a centrifugal force that tries to wobble the wheel outward with every rotation. At around 55 to 70 miles per hour for most tire sizes, that wobble reaches a resonant frequency, the speed at which the vibration is maximized. Above that speed, the forces change, and the vibration often reduces or disappears. That is the tell. A shake that appears at a specific speed window and fades at higher speeds is an out-of-balance wheel almost every time. The fix is a wheel balance. A machine spins each wheel and tire combination, measures where the heavy spot is, and applies a small adhesive or clip-on weight to the opposite side to bring the assembly into equilibrium. The entire procedure takes under 30 minutes for all 4 wheels. The cost at any independent tire shop runs between $20 and $50 for a full 4-wheel balance. Many tire shops include it free with a tire rotation, or offer it as a complimentary service after a new tire purchase. The materials cost is negligible. A few small lead or zinc weights that cost cents. You are paying for the machine time and the technician's time to mount and demount the wheels. Wheel balance should be checked every 10,000 to 12,000 miles as part of normal maintenance. and immediately after any significant pothole impact, curb strike, or off-road excursion. A single hard pothole hit can knock a balance weight off entirely, turning a balanced wheel instantly into one that vibrates. Most drivers have never had their wheels balanced independently and have no idea whether their wheels are balanced right now. If you have never had it done and your car shakes at highway speed, this is where you start, before anything else. The question the mechanic should ask you is, at what speed does the shake start, and does it smooth out above that speed? They do not ask that question. They are not diagnosing. They are guessing. And the guess costs more than $30. Section 2. The warped rotor. The brake-sensitive shake that costs $300 to $600. Your brake rotors are the large metal discs, visible through the spokes of your wheels. When you apply the brakes, the brake caliper squeezes pads against both faces of the rotor simultaneously, generating the friction that slows the car. For that system to work smoothly, the rotor must be perfectly flat, the same thickness at every point around its circumference. When a rotor warps, develops a high spot or a thickness variation, the brake pad encounters that high spot once per revolution. At highway speeds, the wheel is rotating hundreds of times per minute. Each encounter with the high spot sends a pulse through the brake system and into the steering wheel. That pulse is the rhythmic pulsation you feel through the brake pedal and the steering wheel when you slow down from highway speed. Warped rotors are caused by heat. Every brake application converts kinetic energy into thermal energy. Your rotors absorb that heat. Under normal driving conditions, the rotor cools evenly between applications. But panic stops. Repeated hard braking on a long downhill grade, or holding the brakes while cooling, stopping the car and keeping the hot pads pressed against the stationary rotor, creates uneven heat distribution that permanently deforms the rotor surface. Cheap rotor materials warp faster. Oversized wheels with undersized rotor clearance warp under heat that a properly matched system would handle without issue. The diagnostic is specific, and you can perform it yourself before you go anywhere near a shop. Get the car to highway speed. Note whether you feel anything at all with your foot off the brake. Now apply the brakes gradually from that speed. Does the steering wheel pulse? Does the brake pedal pulse under your foot? Does the shake intensify specifically when braking? If yes to any of those, warped rotor. Not wheel balance. Not wheel bearing. Rotor. The repair is brake pad and rotor replacement. On most common passenger cars, replacing pads and rotors on the front axle, which handles the majority of braking force and therefore warps first, runs between $300 and $600 including parts and labor at an independent shop. According to current Repair Pal and Consumer Affairs data, front axle only, which is typically all that is needed. For a shake that appears specifically under braking, the shop will remove the caliper, slide out the old rotor, press in the new one, replace the pads, and torque everything back to spec. This is a 2-hour job on most vehicles, and a procedure that any competent independent mechanic handles without specialist equipment. The thing to avoid is a shop that recommends resurfacing, rather than replacing worn rotors. Resurfacing, machining the rotor surface flat on a brake lathe, is only appropriate on rotors that are significantly above their minimum thickness specification. Most modern rotors are manufactured so thin from the factory that resurfacing leaves them at or near minimum thickness, at which point they are prone to warping again within months. If a shop recommends resurfacing on a rotor that already has noticeable thickness variation and warping, ask them to measure the rotor thickness and show you the specification. If the measurement is within a few millimeters of minimum, replace. Do not resurface a rotor that is already thin. Section 3. The wheel bearing. The constant shake that does not care about your brakes or your speed window. A wheel bearing is a precision assembly of steel balls or rollers, contained in a hardened steel housing, packed with grease, sealed against contamination, and pressed into the hub at the center of each corner of your car. It is the component that allows your wheel to spin freely, while supporting the full weight of the vehicle. When a bearing wears out, either from age and accumulated mileage, from water contamination after the seal fails, or from impact damage, the rollers no longer sit in clean races. They sit in scarred, pitted, or corroded races. The result is a growling, humming, droning vibration that is present at most speeds and does not smooth out the way a balance issue does. The diagnostic tell for a wheel bearing is directional, because the bearing is under different loads. When the car is turning left versus turning right, a failing bearing on the left front will often get louder when you turn slightly right, loading the left bearing, and quieter when you turn left, unloading it. Try it. On a clear, safe road section at highway speed, make a gentle lane change to the right. Does the growl get louder? Then make a gentle lane change to the left. Does it quiet down? If yes, that is your left front wheel bearing. Reverse the relationship, and it is your right front bearing. This is a tool-free diagnosis you can perform in under 5 minutes that tells you which corner of the car to look at. before the vehicle goes anywhere near a lift. Wheel bearing replacement costs between $215 and $650 per wheel, depending on the vehicle, whether the bearing is a bolt-on hub assembly or a press-fit design requiring specialist tooling, and the regional labor rate. According to RepairPal's current data, the national average sits between $343 and $504 per wheel. Unlike the other two problems, a failing wheel bearing is not something to defer. A bearing that is grinding and growling is already past its safe operating condition. The excess play in a badly worn bearing allows the wheel to move in directions it was never designed to move. That movement damages the brake rotor. It stresses the CV joint. On front-wheel drive vehicles, it loads the axle shaft in ways that accelerate wear on every component connected to that corner. And in the most severe cases, bearings that are allowed to progress to complete failure, the wheel can seize or separate from the vehicle at speed. This is not a common outcome, but it is a documented one, and it is entirely preventable by replacing the bearing when it starts making noise, rather than when it decides to stop. The question to ask the shop: which wheel? If they cannot tell you which specific corner is the failing bearing before they start pulling wheels, they have not diagnosed the problem. They have guessed. A competent mechanic will lift the car, spin each wheel by hand, listen for grinding or roughness, and physically check for play by grabbing the tire at 12 o'clock and 6 o'clock and rocking it in and out. That test costs nothing, takes 2 minutes per corner, and identifies the failing bearing before the invoice is written. That 3-question sequence is the diagnostic tool. It takes 5 minutes to run through on any road, and it tells you exactly which conversation to have when you walk into the shop. The mechanic who asks you those questions before recommending anything is doing the job correctly. The mechanic who lifts the car and starts quoting suspension work before asking when and where the shake appears is selling you a diagnosis they invented before you describe the problem. If this video gave you a question you did not have before, subscribe, and I will see you in the next one.